Okay. We're back on. How's the stream quality now? Is it good? Or is it still choppy? Okay, awesome. Cool. And so this is the contest I'm doing today. It was from this morning, but I didn't do it and I didn't look at the problems, so I'm gonna virtually. Ah, is the stream choppy again? Okay. Hmm. Uh, my Twitch dashboard says the bitrate is unstable, but if the stream looks okay, I guess I can just continue. Um, okay, it looks like it's stable now. Oh, chess backwards said it's good as well. Let me see if I can try decreasing the bitrate just a little bit to get it to not say unstable so that I can um, get a sense for. Eh, I'll just leave it, I guess. Okay, I think it's back to excellent. Okay, cool. So I think it just went out for a little bit. Hopefully, there's no major issues. Cool. So I'll set up my virtual participation. I guess the current time. So I'll aim to start in 2 minutes or 1 minute now. So cool. So we're counting down. Please don't spoil any problems I haven't already gotten accepted on. I might have limited chat interaction, but I won't take it too so I won't take this too seriously. So I'll probably still read chat and talk a good amount. And yeah, I'll try to explain my thought process as I go through problems as well. So that should be helpful. I have solved A, B, D, F. Nice, congrats. I'm hoping to solve those as well. Once I get started in 3 seconds. Cool. So let's start opening the tasks. So Takahashi has some programming contests. He needs one of each problem. So how many contests can he hold? So it's just the min of the input. So cool. So let's submit A. All right. B. So at every half minute, or every time that's like a minute and a half, 2.5 minutes, etc., he loses one battery charge. he starts fully charged, visits a cafe m times. And during the cafe, it increases. So we can basically just simulate this by looking at um, what's going on when he gets to each cafe. So let's do B. Okay, cool. So let's say X is his current capacity. Let's say that it's equal to N. And it can only go up to N. Cool. So then we're gonna I call those S and E for start and end. So this is gonna be the time that he's at each cafe. Okay. So X minus equals however long he wasn't at the cafe. So that would be S minus T. And then if X is less than 0, 0. Okay. So I think this should work. It's just a kind of basic simulation problem. All right, pass the samples. So I guess let's just submit. Close. Okay, cool. We got accepted. So there's an iron bar of length L. We want to cut it into 12 pieces. Find the number of ways to do this division. It can be proved the answer is less than 2 to the 63. Okay, cool. So for this, we want to do stars and bars, I think. Yeah. So basically, you imagine you have int L, read L. So we have our n kind of pieces, and we want to put 11 dividers in. Each of the bars must have a positive. Okay, so we can make each piece start with um, and then so we want to find I'll call this Z, and then we want to find n equals. So we want to arrange the L pieces that we have and the Z minus 1 dividers. So I think we can do this. I'll try to do this a more clear way. N minus... So we're basically manually computing this binomial coefficient, and what's kind of cool is these are always integers because each of these represents a binomial coefficient, so you don't have to worry about, oh, what if I divide by this and I get a fraction? Okay. So now we're doing D. Am I in the virtual standings, by the way? Wow, this takes forever to load. Wait, I'm a ghost? Wait, am I not registered? No, I am. I leave for 5 minutes and he's already on D. Yeah. Am I not? Hey Neil. So I don't really understand how my virtual participation works. Because I'm not in the virtual standings as far as I can see. Oh, okay, now I'm in the virtual standings. Great. And my rank is continuously dropping. Makes sense, because I'm not even doing anything. Okay. So we have n squares. Let square I be the ith square from the left. Squares. Okay, so some of them are blue, some are white. Huh. Is it always possible? Oh, we can choose K. Okay, awesome. So we basically have a bunch of white intervals, and we want to paint them all red, and we can't touch the blue intervals. So what we want to do is we want to find the size of all these white intervals, and then we want to make K small enough that we can paint any one of them. So let's read the input. Int So what we want to do here is find the lengths of all these intervals. So let's sort A. Oops. And then let's add a fake blue square at 0, and then another fake blue square at n+1. So that way, if we just look at all the differences between those will tell us our white intervals. So I'll call those B, I guess. And let's just try printing this to make sure we didn't make a small mistake on like one of the samples. So for the first sample, we have 0, 0. Okay, that's definitely, that doesn't look right at all. 1, 3. Oh, I'm reading M again. Right, I want to read A here. The next XQC. Yeah, I heard XQC is a famous chess streamer. I think he competed in a serious tournament called PogChamps. Cool. So now int k equals min element all b. So we want k to be the smallest element in b so that it fits inside every element. And then finally int ans equals 0 for int b colon b. So to paint an interval of length v, we need v plus k minus 1 over k uses of k. This is just dividing and then taking the ceiling instead of the floor. No, I guess this is wrong. 3 uses are enough. I guess maybe I should be printing these arrays so I can actually debug this. Will you be? Yeah, I'm gonna post this on YouTube. I'm behind on a couple YouTube videos, but in general, I post everything on YouTube, and it's pretty easy to watch there too because there are timestamps. Okay, let's see. Oh, yeah, okay. I need to subtract 1 from all the elements of B. Wait, is that right? Oh, and then I guess I want to eliminate the zeros. Well, this is actually a pretty tough one. Okay, cool. Definitely a bit tricky. Definitely liking C++ so far. Having, like, being able to do min element, things like that, super nice. Great. All right. Let's look at the standings. I'm going to see which of these problems has more solves before I read them. Well, I guess I'll start reading. So we have two sequences of length n and m. Oh wow, f actually has more solves. Let me read f then. So we have to replace, so we have to XOR a value, or we have to print the x, whoa, or print, okay, I don't want to read that. Well, I'll leave it up for viewers maybe. But yeah, XOR is basically just this operation. You can treat it like addition, but it's its own inverse. So if you XOR something with something else twice, you get the original thing back, which is kind of cool. Kind of like multiplying by -1. Um, so I think we can do this using like basically a segment tree. Yeah, we just replace elements or we do a range query with this nice associative operator. So yeah, I'll try solving f first. I'll actually use a Fenwick tree. Does this work? Um, so I'm gonna overload plus and minus, and maybe this will just work, which would be kind of cute. Um, Using this as an opportunity to try to learn some C++. I don't know. Is there a better way? Is this a syntax error? Do I need to define a constructor, I guess? All right, let's say there's a constructor here. Yeah, okay. I've never written constructor in C++ before, actually. Like, I think ever. um, Hopefully there's a better way to do this, but I'll learn about that after the stream. Oh, awesome. Thanks. Um, so for type 1 queries, we want to do a replace. And then for type 2 queries, we want to print. All right, let's try running this. After the stream, I'm definitely going to try to see if there's cleaner ways to do this, like write implicit casting. Yikes. Okay. Let's see what I've done. What are these giant values? Uh, do I not want... Oh, do I have to initialize v explicitly as 0 for like my default constructor? Let's try that. Oh, okay. Maybe that's just the issue. Well, I'm still getting a sample failure here. On sample 1. Okay. Let's see. Oh, I see. We want to do this. We don't want to just replace it with y. We want to XOR the existing value with y, which is the part that I forgot here in my code. Okay. Let's try submitting this. Just call add. Yeah, fair enough. Replace is definitely slower here. And less clear. All right. Awesome. All right, let's do E, the last problem of this set. And then later I'll try to brush up a little on my C++. Brush up is the wrong word. That makes it sound like I used to be an expert and I forgot everything, but in reality I just never was an expert. Or I guess I'm gradually trying to become an expert over time is a more positive way to look at it. So this new sequence is literally, this is a definition of a subsequence. You remove some elements and you concatenate the remaining elements. And same here. So this is, wait a second. Let x be the total number of elements removed. All right, seems legit. And we want to make I the number of integers such that, or sorry, y is the number of integers so that you have a different value. So you wanna, this is almost like finding the longest common subsequence, but there's a slight difference, which is we want to find the minimum, we wanna, sometimes it's okay to have an element that's different because at least we didn't have to use operations to delete the element. So it's almost the longest common subsequence. Yeah. This isn't right. Trying to bring up a whiteboard that we can use. Okay. Cool. So here, let's see. So length A prime equals length B prime And let's just call this L. So then, whoops, x equals n plus m minus 2L. So we want to minimize x plus y. So we can maximize n plus m minus x plus y, which would be 2L plus y. So basically, for every... Is that right? So for every character longer we make the final strings, we get 2 points. And oh, right, this should be minus y. That makes more sense. And then for every character that's different, we want to lose a point. So well, I guess without thinking super hard about it, I think we can probably just do a regular longest common subsequence DP, but just change it slightly. So let's start by trying it like that. Hmm. What do we want to do? Actually, maybe that doesn't really make sense. So I was thinking we take a prefix of both arrays and we consider adding an element to the subsequence. All right, maybe this problem requires a little bit more thinking. All right, so they have an example here. Let's see if we make a prime. Well, so I guess one thing that's slightly interesting is in all these examples, they remove nothing from one of the strings. So let's think about why this would be the case. If you remove something from both strings, what would that do? I guess maybe let's try to construct an example. So you have 1, 2, 3, 4 as the shorter string, and then you have 2, 3, 4, 5, 6 as the longer string. So this makes it seem like we really want to remove this 1 to make this stuff get shifted over. So let's look at what happens if we don't remove it. So case 1, we have 1, 2, 3, 4, and 2, 3, 4, 5. So then 2L minus y here would be 8 minus 4, which is 4. And then case 2, we have 2, 3, 4, and then 2, 3, 4. And then 2L minus y here would be 6 minus 0, which is 6. Okay, so it actually is sometimes beneficial to remove things from the shorter string. The samples just didn't cover this case. So let's, before we forget, let's add a sample that does cover this case. 4, 5, 1, 2, 3, 4, 2, 3, 4, 5, 6. And then I guess the optimal answer would be you remove 1, 2, 3. You remove 3 elements. So, okay. I mean, so this 1000 is really saying like we probably just want to do like some kind of two-dimensional DP. So there might be another way to think about it. That's kind of nice. Um, I was thinking we kind of think about it like we can transform elements of one array to try to maximize the length of the longest common subsequence. Yeah. So for this example, the answer is just we want this as our longest common subsequence. But let's try one of the other examples from the input. They have 1, 2, 1, 3, and 1, 3, 1. So here, the longest common subsequence is just 1, 1 or 1, 3, which is length 2. And if we just deleted stuff to get to that, that would give us a score of 2 times 2 minus nothing. But then if we allow incorrect elements, we can get a longer common subsequence. Right, so the optimal answer, you end up getting 2 times 3 minus 1, which is 5. So you can kind of think of it like we can take this 3 and transform it into a 2. And now the longest common subsequence is 1, 2, 1. And you have to pay 1 for each transformation of an element that you do. By the way, let me know in the chat. I'll type this. Cool. So when we do a normal longest common subsequence DP, we're saying for each value yeah, hang on. So I think what we can do is we can actually just do a normal longest common subsequence DP, except you have this case where the two characters are equal. So now you have to add a case where they're not equal, but you can still like try to proceed, but then um, you take a penalty of 1 because you had to pay a little extra for the transformation cost. Um, so let's optimize 2L minus Y. So initially, when you have nothing, the answer is 0. Um, yeah, so let's go through all the letters in A. And then all the letters in B. So, or I guess maybe I'll do it like this. Yeah, okay. So, in U equals AI. Um, all right, let's see if this actually makes sense. All right, I have some kind of yeah. So here I want to do +1. So in this example, from the input, the optimal answer here would be 5 for 2L minus Y. Um, then here, the optimal answer would be 6, which is what we expect. Okay, cool. So now, an answer equals n plus m minus. All right, so this passed the samples and even passed my supposedly tricky sample. So I'll just try submitting it. Cool. All right, so I guess the contest is over. Let's see if I got anywhere close to the top. I got 7,000. Wait, hold on. That's not right. Is it? I don't really understand how this works. So I got 194th, I guess including real participants. I guess I got a score of 40/30, so I could look at the regular standings, which I actually understand how to read. E is literally just Levenstein distance. Um, Is that right? Yeah, I guess so. 'Cause like deleting from B is kind of like inserting into A, and then I guess that's like a nicer. Well, I don't know if it's nicer or not, but that's a different way to, I guess, come up with like. I guess my intuition was like, oh, we can consider like, what if we can transform a value for a cost of one, and I guess that's basically equivalent to the edit operation from Levenstein distance. It means you can copy paste a distance code. Yeah, that's definitely good. I do love copy pasting code. Um, cool. So now that the contest is over, I can actually talk pretty freely. So if anyone has any questions also about any of the problems, or I should explain any of them in more detail, since I was a little bit focused on just trying to do the contest. um, Definitely happy to do that. Uh, yeah, I guess let's see. Wow, a ton of people did this super fast. Um, Ui, I think, is a common top participant. Oh, wow. C and E. Okay, cool. Yeah, let's go over C and E. Um, do you have a preference for which one we go over first? I guess I can go over C first. It should be quicker. Um, so basically, C features this standard counting technique, but basically for C, uh, let's instead of 12, let's say we want to divide something into three pieces, just for an example. And then let's say the original bar is of length 10. So one such way to do that would be like 5 plus 4 plus 1. So you can imagine it like you have these 10 pieces of the bar. Well, I guess another thing you can do is, right, they said every piece has to be positive. So you can subtract 1 from each one. So then you get 4 plus 3 plus 0 would be 10 minus 3. So you can imagine you have these 7 balls that you want to, or pieces that you want to distribute between the things. So you can do that by just placing two dividers in. I guess I'll make this correspond to my example. And the dividers can actually be after the end. So you can see the last one has nothing in it. This one has 3 and this one has 4. So the number of ways, so now you have these L minus 12 balls plus your 11 dividers, and then you want to choose, that's the total number of places that you have to put stuff, and then you want to choose 11 places to put the dividers out of all those blanks. And this is called stars and bars. Definitely worth understanding intuitively, because I think there's a ton of problems where this shows up or something similar shows up. Um, so I'll paste the link in the chat. Cool. And then for E, we already kind of discussed it a bit. Um, so the way that I thought about it, it sounds like John in the chat had a bit of a different approach. So I don't know if he wants to outline kind of how he saw that that was correct in the chat or not. Um, Man, I don't want. Alright, banned. I guess it's cool. You know, I'm big enough that I'm getting spam bots, though I imagine there isn't a lot of barrier to entry to adding a spam bot. Cool. Um, so yeah, I guess I'll try to outline E in a little bit more detail. So for E, what you can do is let's read the problem again. So the way that I thought about it is you want to maximize 2L minus Y, where L is the final length. So if you're doing that, you can do a two-dimensional DP that's almost the same as the longest common subsequence DP. So I'll just I'll paste that in the chat too. But this is like a pretty standard problem. I definitely recommend being familiar with it. It's not super common for this problem directly to show up, but it's very common for a variant of it or the ideas behind it to show up. But basically, your transitions are if you have your prefixes of the strings, let's say these are your two string prefixes, and you have the best possible answer for the prefixes, then if you're adding characters U and V like this, if the last characters are U and V, you can either choose to remove V, in which case the answer would be, or remove U, and then you would get this, or you can choose to not use V, in which case you would get this, or you would choose to use both of them, in which case you would get and then here we would add 2 if U equals V, because we're increasing the length of both strings by, or both subsequences by 1, and not changing Y, or we could add 1, because we'd be increasing the length of both subsequences by 1, but increasing Y by 1. So if these are your transitions, then, oops, edit E. Oh, whoops. Okay, cool. So you just do a DP and you take these transitions that we wrote and you code them up here. You either have 1 or 2 here based on whether the values are the same or not. Cool. Yeah, hopefully that makes sense. Yeah. Cool. Maybe I should outline the other problems briefly, and then kind of end the stream. So let's see. I guess I'll start with A, just because it's fastest. Well, yeah, I mean, so for A, right, you're limited by whichever problem you have the least of, so the answer is the minimum. For B, I guess this one I already kind of explained was a simulation problem. You just go to every time and you see what's happened since the last time that we had to process an update. Cool. So now let's look at D, which I actually thought was pretty interesting. So I'll just draw out one of the examples from the input. So here we have one, I'll use black. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I went to sleep and woke up. You're still streaming. Yeah, so I went to sleep and woke up. So I was streaming last night, and then I'm streaming again right now. So I slept, I had dinner, I had lunch, all kinds of stuff in between. Um, yeah. So I'll use a text box here. One, two, three, four, six. Okay, cool. So then in this example, um, we have 3, 9, and 13 are blue. And then we're going to add fake blue cells at the beginning and end. And then what we do is I'll use red instead of white for what we want to turn red. We have this, 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 and then this, which is 0. So that's 2, 5, 3, and 0. We don't care about the 0 since there's nothing to do there. So what we want to do here is we want to find some stamp that we can cover all of these with without going over the bounds. So the stamp has to be of size 2 or smaller. So let's just take the maximum size 2. So we can use 1 stamp to cover this, 3 stamps to cover this, and 2 stamps to cover this, like so. So this is 2 over 2, and then you take the ceiling, plus 5 over 2, and then you take the ceiling, plus 3 over 2, and then you take the ceiling, which gives you your answer of 6. And the code for that is here. Basically exactly as I outlined. First you sort the A elements so that you can find all the differences between them, and then ignore the zeros since we don't care about those. And then K has to be the smallest interval size, and then you take the ceiling of this stuff. Yeah, by the way, if you're watching, definitely please consider following. That would be awesome. I'm trying to pump up my following numbers. I'm new to streaming, so I think every follower counts. And also, I'm going to post this video and my other videos on my YouTube. So if you subscribe there and watch there, if you miss a broadcast, that would be really awesome. Cool. And then the last problem I'll consider doing F is this range XOR query problem. So for this one, there's basically a standard algorithm called Fenwick tree, or a standard data structure rather, which they don't have they have a picture. Basically what this allows you to do, if you read here, it lets you compute some function of a range efficiently and update a value efficiently. And if you look here, they want us to compute this function of the range, and they want to update values efficiently, which is exactly what a Fenwick tree does. So I just have this pre-written Fenwick tree code. It's also called a binary indexed tree. And then I define this custom struct here that replaces plus and minus with XOR and XOR. Yeah, no, I finished the contest maybe 10, 15 minutes ago. Yeah, so I've just been going over the problems and now that we're done. What standing did you get? Virtually. Okay, so I'll remove ghosts then. So I got third out of all the people who did it virtually, but not that many people do these contests virtually. Usually people do them kind of actually. So I finished all the problems with a time of 40:30. So if we look at the standings, um, scroll down a bit, find out where we reach 40:30. So I would be between these two people. So I would have gotten around 190, 191, 192 place. Um, and then let's try to get a sense of what my performance would have been. I have a feeling this might have been a not great performance just because E and F were both very standard. So it was definitely possible to do them very quickly. And I took a while on F, or sorry, I took a while on E. I think F I did pretty quickly. So if you look at only rated participants, is that what I did? Yeah. And we scroll down. We'll try to find somebody who did basically the same as me. Yeah, so TSPCX, who got 30 or 80th, nice job. And Q Mazaki, and Neko Naya did around the same as me. So we can check their rating changes. Oh, this actually has the ranks on it, so I could have just looked at that. So I would have gotten around a 2200 performance, if this were rated for me, of course, which it's not because Atcoder beginner contests are only rated if you're below 2000. But that's actually better than my current rating. So in theory, if I could have done this contest, I would have gained a little rating, which would have been nice. Um, but that's very theoretical because, one, I'm not eligible to do it, and two, I didn't wake up in time to do it. But yeah, cool. So that wraps up this contest. So I think I'm going to wrap up the stream now. Thanks everyone for joining. If you're not already, any tips for avoiding segmentation errors? That's a great question, actually. So I used to code in Java, which chess. Oh, do you want to play chess? I'd be down to play chess with viewers. Let me know if people would be interested in chess with viewers. If so, I'll do it. If not, I won't. Bore you. um, But to answer this is Anonymo's question about segmentation errors, I assume you mean like if you do like array index out of bounds and stuff. So in Java, it was pretty nice because they would tell you exactly where your array went wrong and on what line, almost out of the box. In C++, I believe you can turn on some bounds checking. I'll try to show my compile command. So I have this glib cxx assertions. So if you end up having an invalid array or an invalid index for something like a vector, it'll always crash. So you don't have undefined behavior, which is good. And then I have another build command, which is a lot slower, that has glib debug. And what that does is it tells you something like, oh, you tried to access element 8 of a vector, but it only has 6 elements, so that's not valid. So that definitely helps, but if you're able to find where the error is, but you cannot solve it, that's definitely unusual, right? Like, you could just try printing the index before every time you access the array, and then just try to figure out where in your. So that's like a deeper logical problem, right? Probably like, like if I were doing this and I had I minus 1 and that ends up being negative 1 because I started I at 0 in this example, that would be kind of a logical error here where I need to check for that case. So I could try here, like printing I, and then I see that it's negative 1, and then I'm like, oh, I should change my indices. But that's definitely something that comes with practice. Um, yeah. uh, Sometimes in programming contests there's a memory limit, or I guess always, but usually the limit's very generous, so I wouldn't worry about it. Very rarely you get memory limit exceeded, but it's more often that you'll get time limit exceeded if you're using that much memory. Cool. So, yeah, if people would be interested in a couple games of chess with viewers, let me know. If nobody wants to play or watch, then I think I'll end the stream. Um, but yeah, hope everyone's having a great day, and thanks so much for tuning in. Maybe I'll play one game of chess. Nah. Yeah, I think I'll end this stream for now. All right. Thanks so much, everyone. And definitely drop a follow here and check out my YouTube, um, where I'm going to be uploading this video as well as my other past broadcasts. So they should all be pretty easy to watch there. Cool. All right.